And here we go, the quick answer key to solving the water piano circuit, all done at high speed. So we've moved everything onto the printed circuit board. Let's start arranging it. And here we go. So zoom in, starting to move around the arrangements. Now I'm trying to get the air wires to line up so I don't have that much crossing. Now this is just a first draft of what we're doing, and I've got them lined up. So here I come into the design rule check, and what I'm trying to do in here is set all of the dimensions in that, and also set it to a single layer board. So that was the first thing I did in there, and now I'm coming along and setting some of the dimensions. And when we do a design rule check later on, it will check to make sure that everything is in there. I did a DRC right then and didn't really need to. Oops, it was in red. That means it's on the top layer. Get rid of it, come back, change layers, put it in blue. Here we go. We're going through and we're routing various components. And you'll notice that the line is thick enough that we can actually etch that using our in-class toner transfer etching tools. You don't want to have super thin lines. This is being controlled by one of the settings that we set when we did our design rule check. So go back a few seconds on here. So I'm playing around with some of the component locations and trying to find ways that I can route underneath here. If you've ever played the computer game Flow Free, you can get it as an app for your phone. It's good mental practice for what we're doing right on here, particularly if you do the Flow Free with bridges option. And right here I'm puzzling things out. Will that come around right there? And trying to make sure that I don't double back on loops. You can go underneath an integrated circuit, just try not to go in between the pins, because although technically you can do it with a super fine line, you'll regret it later on when your students try to make something like this. Okay, that was a little pause to think right there, and you can see I said, oh, I didn't like where that was, so I deleted some of the traces that I'd made. That's sometimes easier than trying to fix them up later on, and then I move it around and just use the air wires in yellow to try and position things. And I'm saying, okay, well, if I put that over here, then I can use that to jump over top of one of the other signals. And there we go. A couple of lines go in right there. That trace can run like so. I've still got one that's causing me a little bit of grief. So now I'm going to take a look at that right here. And maybe if I move those pads over to the other side of the board, maybe I didn't have it so brilliant the first time around. Let's try moving this over here. Trying to find a place for that to fit. Got to move a couple of the other components. There we go. Ran that line underneath the resistor. Put that underneath the resistor. Okay, whoops, problem touching the capacitor down there. Got to move that capacitor over a little bit. Whoops, that's not a capacitor. That's a speaker. What am I talking about? Anyway, let's move this around right here, and we can bring that pad. This is one of the pads that are going to go off to one of the wires that the person touches. We bring that over to right here. Get everything lined up on there. We're getting closer now. Let's bring that in right here. Bring that over there, and do we have it? Is it all done? We got to run something over here. How do I get into that spot? Uh-oh. So time to clear out some of those lines and rotate that around. Let's move it, and let's use that capacitor to jump over top of that trace right up there, because that trace was getting in the way. Let's delete that, move that over right there. Now you see I've got space underneath the capacitor, and I can route that wire up over top of there. And that gets rid of one of my crossings. Down here, I can move this around to make it a little bit neater. And here we go. That line comes out there. That one comes over there. Oops, still got to do this one. How the heck am I going to do that one? So let's see, that's going to come out there. All the way around over there. Now keeping that nice and parallel and lots of space right in there. And I didn't actually have to join right to that spot because the trace was already connected in there. And now let's shrink our board down to size and take a look at that right there. It's looking reasonably compact, making good use of the space. Try to keep our lines nice and neat and parallel. And yeah, may as well make the board look good. I did a design rule check right there. It didn't beep at me. There's no errors. Well, I'm just didn't need to click on that right there. I was just trying to think, did that show me the design rule check results? But the design rule check came out clear. There were no errors. So here we go. We need some mounting holes for the board, and let's put them on there and get them about the right size. Do a copy and paste. And mostly what we're doing is we're showing that we've left room for mounting. Now, usually on a small board like this, 2 holes is going to be enough, but let's get everything aligned here as best as we can. The numbers on there are going to show us whether or not it's aligned. And I'm putting my name right on here, and you can rotate your name around here if you need to do that to make it fit, because unlike the schematic, when we're looking at this, we are going to be able to rotate the board around to look at it from angles, bring those edges in a little bit closer, get those mounting holes squared up a little bit nicer, and take a look right in there. And what do we got going on right there? Oh, okay. I'm trying to right now find out if I can put a dot onto that component to indicate pin 1. I can't put a dot onto that component. So this isn't a necessary thing, but it helps when somebody's making the board. I used the Alt key while I was doing that to get away from the grid. Alt lets you not stick right onto the grid. And here we go. I'm doing a print now, and I want this to come out all in black and to be solid. And I should have saved it to a different file. Here we go. Let's try it again, and let's put it onto my desktop. I really don't like saving things onto my desktop, but I'm going to delete this in a moment anyway. And here we go. Comes out on the desktop. And where did the file go? File, where are you, darn it? There you are. And here we are. Let's take a look at this file right here. And of course, this isn't what I'm going to submit because I can't print that because it had all of the components showing. So if I tried to do a toner transfer with that, it wouldn't work. So I come in here and turn on the layer function, turn off the layers that I don't need. So I just go to the bottom copper layer and let's print that out. And hey, that looks like a half decent circuit. Okay, let's put some notes on here so that people know what we're talking about. And there's that little dot that I put in, and that will just help somebody align their chip to make sure they've got pin 1 in the right hole. You will appreciate that when your students don't put things in backwards. There's our mount holes right there, and just putting visual notes on there. And man, if only I could have typed this fast at 400% speed back when I was in typing 10, I would have been the star of the class. So just a comment on there that wires that run off the board for people to touch, they need to be strain relieved. Otherwise, they'll fray and break at their soldering point right in there. And this is where our switches and battery are going to go, and really those are just wire connections. And again, if they're going to be flexing around a lot, you'll need some kind of strain relief for them. Make sure you've got your name showing on there. Of course, it's going to be mirrored because right now we're looking at the top of the board and everything's down underneath. So that's a good sign that we got that on the bottom copper layer. And that'll do a toner transfer, and after the toner transfer it will look just fine on the bottom layer of the board. And a comment that we're keeping things nice and neat. We're not double backing on lines. You don't see any kind of U shapes on there. We'll have parallel lines, we'll have T shapes, but no big U shapes where you touch on one pad, then go out, route around something, and then come and touch to the pad right next to it. We're trying to find a reasonably direct line to do that. So anyways, just a few comments on the board. Let's go back and just take a look at the schematic on here. And again, we'll print out a PDF copy of the schematic. We may as well save it to the right place to begin with this time. And let's do it in color because color isn't a problem for the schematic. There's our schematic right there. And it's mostly good. It's easy to read, but I've got a few comments on there that there's things that could be done better. A lot of this is because Fusion 360's electronic CAD, although it's based off of Eagle, which has been around for a long time, is still a fairly new package. And I think it only came out in November. This is March right now, and this is the first time I've really delved into it too deeply. So I've got to go through and build up my libraries and get my expertise back up where it is with DesignSpark, the package that I've been using for the last 10 years. Anyway, there's some nice features about having this all in Fusion 360. It certainly makes sharing the files easier, and it's definitely easier for people who run on a Macintosh and don't have access to a PC right now while we're all staying at home and trying to get our hands on this global pandemic that's kind of upset the apple cart a bit, to put it mildly. Okay, there we go. That's the two files that we're going to have when we're all done our board. We're going to have a toner transfer image that we can take to a laser printer, print it out onto toner transfer paper, and that will let us create the actual circuit board. And then we're going to have a schematic that we can share with people. The schematic's going to have all the values displayed on here, and it's going to let us let the person assembling the board know where to put all the parts and explain a little bit about how it all comes together. Hope that answers some of your questions and gives you an example of how I would solve the water piano routing problem.